It's an encouragement that has been judiciously allocated to our younger ones among that members of PSSN. They are listening as I'm talking. Some of them are here physically, some of them are online. That they are participating based on the benevolence of Professor Kasim Malibojo, sponsoring their participation at the 60th International Conference. Paying for their conference fees is not a small milestone. It's a big step in the right direction. I want to enjoy others to our colleagues, our friends too, to take this as an example, a very good one indeed, to leverage upon subsequent outings that we can encourage our younger ones by encouraging them in terms of financial encouragement, even in terms of the intellectual encouragement, whatever form, to ensure that the vision and mission of PSSN is attained. Thank you very much once again, Professor Kasim Adeboju, for this wonderful gesture. On behalf of the Council of the PSSN, we say thank you, and thank you, and thank you. This program is being proudly supported again by the Novartis Group Consultant from the US. And this we are not taking for granted. We appreciate them as well. And of course, our hosts, the management of Yaba College of Technology, Yaba Lagos, under the able leadership of our dynamic rector, who was here 2 days ago to give us a keynote address. We really appreciate you. We appreciate your gesture. We appreciate your contribution. We appreciate your hospitality, the hands of hospitality, the excellent one indeed, extended to PSSN and the executives. Again, I appreciate the co-host of this year conference. No other organization than the NIMA, the Nigerian Institute of Medical Research, very close by here, under the able leadership of Professor Babatunde Lawal, as Director General of that great research institute, who is hosting this 60th International Conference. We had our recovery workshop at that NIMA, a very hospitable environment, serene environment, and it took us to what I can call first class level of treatment while we were there. We are still there, we have not left the place, and we really appreciate the Director General of NIMA for giving us that beautiful and giant support. On this note, I want to thank all our participants, either here or online, for being part of us and our committed members. Thank you very much. So without wasting much time, we will bring forth those that will present in person this morning. They are just two here in succession, after which we dissolve into parallel sessions. Thank you very much as you join us.
Arise, O compatriots, Nigeria's call obey, to serve our fatherland with love and strength and faith. The labor of our heroes past shall never be in vain. To serve with heart and mind, to serve our fatherland with love and strength and faith. The labor of our heroes past shall never be in vain. To serve with heart and mind, to serve our fatherland with love and strength and faith. The labor of our heroes past shall never be in vain. To serve with heart and mind, to serve our fatherland with love and strength and faith. The labor of our heroes past shall never be in vain. To serve with heart and mind, to serve our fatherland with love and strength and faith.
Okay. Can you test that? Okay. So, good morning once again. The first presenter today is Dr. Yinais Uwai-Juno, and he will be speaking to us on the paper titled Spatial Temporal Meaning of Severity of Malnutrition and its Associated Risk Factors among under 5 children in Nigeria between 2003 and 2018. She will be speaking to us for 15 minutes, after which we'll take questions and comments. Thank you. Let's welcome her to the
all protocol observed. I am Dr. Eunice Uwai-Juno. I have the privilege to present this paper entitled Spatiotemporal Modeling of the Severity of Malnutrition and its Associated Risk Factor among under 5 children in Nigeria between 2003 and 2018. This paper is co-authored by Professor Adebayo and Dr. Diana. This is the outline to the paper. The nutritional status of a child is an integral part of its physical and mental well-being. Severe malnutrition in early childhood often leads to deficiency in cognitive development, school achievement, productivity in adulthood, and undue pressure in the immune system. Malnutrition among children is one of the major causes of morbidity and mortality. In fact, undernutrition is associated with 25% of child death. Now, what is the form of malnutrition? Malnutrition in child comes in 3 forms. We have the acute, the chronic malnutrition. We have the chronic malnutrition, and this is a measure of height for age, which is known as stunting. We have the acute malnutrition, which is a measure of weight for height, which is known as wasting. And we have the chronic stroke acute malnutrition, which is a measure of weight for height, which is known as underweight. Sometimes it can also be known as overweight. These anthropometric indices are commonly used to measure child nutritional status. The AIs can be expressed in standard deviation units from the media of the reference population according to the World Health Organization Child Growth Standard. Children with AIs that are below -0 is considered to be malnourished. Now, figure 1 gives the global burden of malnutrition. You can see for the 3 phases, you can see that we have up to about 144 million children are stunted globally. We have about 47 million children to be wasted globally. Now, what about in Nigeria, our country, Nigeria? Nigeria has the second highest burden of stunted children in the world, with a national prevalence rate of 32% of children under the age of 5. Given these statistics, our main modeling question to be addressed using the Bayesian modeling framework is, how do you model the severity of malnutrition and its associated risk factor among children under the age of 5 between 2003 and 2018 using the Bayesian multi-level structure addictive model? The data. Our variables of interest for this analysis were extracted from the record data of the 2003, 2008, 2013, 2018 from the Nigeria Demographic and Health Survey. In the dependent variable, we consider ordinal categorical variables for stunting, for wasting, and for underweight in accordance with the World Health definition of anthropometric indices. Thus, for stunting, our dependent variable has this form, given in equation 1. We have this for wasting, we also have this for underweight. Now, for the independent variable, we consider three categories of covariate. We have the background characteristics, the social-demographic characteristics, and the biodemographic characteristics as given in table 1. The model for this analysis is given in equation 2. Now, a number of authors have attempted to model the severity of malnutrition in Nigeria, but our model stands uniquely different from other work in the following, considering the following reason. 1, unlike other work that have not really used the Nigeria Demographic Survey, our model have used that data. For few works that have used that data, they have not considered the spatial variation, which is considered in our model. Another hallmark for our model is that most work have relied on just one survey or 2, but our model have used 4 waves of survey. The data construct from this combined data set has not been used to the best of our knowledge. Also, our model, we have also used variables like ethnicity and cluster numbers as our random effect, which to the best of our knowledge has not been considered in previous work. Also, the biodemographic data that we have used with reference to the 3 anthropometric indices has not been exploited to the best of our knowledge. So with reference to existing work, we consider our model to be unique. Estimation of parameters. Bayesian inference requires that appropriate para be assigned to all parameters of interest. So for the fixed effect parameter, we assume the diffuse para. For the nonlinear parameters, we use the Bayesian P-plan given in equation 3. The BJ are vectors of regression coefficient, which are defined to follow a second-order Bayesian model random walks smoothness para given in equation 4. For the random effect, we assume the exchangeable normal para, and for the spatial effect, the Gaussian Markov random fixed para was assumed, given in equation 5. This special effect was again splitted into the structure and the non-structure. For Bayesian inference, the variance component are also considered to be random, and so para are being assigned to this component. Now, kappa crowd are assigned to this component, and this crowd are inverse gamma crowd with a probability density function given in equation 6. A unique feature of this probability density function is the parameter AJ and the parameter BJ. Bayesian difference require that a very small value be assigned to this parameter. And so for parameter AJ and BJ, 0.001 was being assigned, and this is also the default in base S. Now, Bayesian difference is based on the posterior analysis of the cumulative probing model given in equation 7. In real life, this equation is numerically intractable. So a common way to resolve this problem is to use the Markov-Chain multicolor simulation, known as the MCMC simulation. So what this does is that a Markov chain is being created from which samples are being generated, and the posterior mean and other parameters of interest are being generated. More details about how this Markov chain works can be found in the manual of base S. Model diagnosis was based on deviant information criteria, and the model with the lowest TIC is considered to be the best model. Table 2 gives the model diagnosis, and as you can see across the table, model 6 is considered to be the best model with reference to the 3 AIs. So our analysis or our result will be based on model 6. Now, result for the fixed effect. Now, in this result, all the estimates with positive values are considered to be estimates with better heads, and those with negative values are considered to be estimates with poor head. Because of time, we will just dwell on estimates from stunting. You can see that for a year of study, with reference to the base year, which is 2003, children are less likely to be stunted in 2013 and 2018. For sex of child, male children are found to be more stunted compared with female children. For mother educational level and also for wealth index, we saw a similar pattern that children are less likely to be stunted as the mother educational level increases and as their wealth index also increases. Children from home with protected source of water and improved toilet, children from such home are less likely to be stunted. Now, children who have their delivery in the hospital and those who have large size at the point of delivery, we also consider to be less stunted. However, children who have diarrhea and have fever 2 weeks prior to the survey, they are found to be more stunted. For the nonlinear effect, considering the age at marriage, you can see that children were more stunted for mothers who are between that mother up to 18 years of age. So children from teenage mother are found to be more stunted. For mother body weight index, we can see a linear relationship. The higher the body mass of the mother, the less stunted the child is. For child age, we also notice that between 0 to 20 months, children were found to be more stunted. After that month, we found a sinusoidal pattern. Then for mother age at birth, we notice that children whose mother are older in age are less stunted. Now for the spatial effect, the color map gives the spatial variation across the state, and the map that are black, gray, and white help us to explain the significance of this variation. The states that are white are states with higher estimate, so children from that state has improved health. States that are black are states with lower estimate. Children from that state have suffered from malnutrition, while the states that are gray are insignificant. So for our structure and unstructured effect, for our unstructured and structured effect, we really did not find any significance. But when we took the sum of the structure and the sum of the structure, so when we took the sum of the structure and the unstructured, we found something very interesting. We noticed that states like Sokoto, Zamfara, Benue and Adamawa has high estimate because those states are in white. So children from that state are found to be less stunted. However, states like Kebbi, Kwara, Yobe, Gombe, and Bauchi are significantly associated with stunting because those states are in black. Other states were not significant. Now the conclusion. From our study, the study shows that the study found children of working mothers to be less likely to be stunted. Thus, they found they strengthened the need for women empowerment as a means of ensuring the well-being of their child. The study found younger age at marriage to prohibition, particularly below 18 years of age, to be associated with stunted children. A possible strategy to resolve this is to reinforce the implementation of child rights acts. This episode of diarrhea and fever 2 weeks prior to survey, they also found to be negatively and significantly associated with stunting and underweight. A possible recommendation is that preventive measures such as immunization and sanitation needs to be reinforced in the country. Thanks for listening. These are the references to the work. Thank you.
Can we put our hands together for the presenter? Thank you. Please don't go yet. You have to stay for questions and comments and all that. I'm very sure that this is a very interesting work that will generate so many questions. Going forward, I want to ask if there are questions here. If there are questions here, please you can signify. If you to our online participants, you can use the icon. I've seen that. I've seen Dr. Chris. I've seen Professor Kazim. Yes, we'll take it from here first. Then we'll revert back to those online. So I give you number 1. Okay, number 2, Prof. number 3, Prof. number 4, and number 5. Oh, okay. So I give you number 5. Then I'll number 6. Then we have, where's Dr. Chris? He's no longer here. Okay. Professor Kazim will be number 7.
I'm here.
Okay, don't worry. You are number 8, sir. Okay?
Okay.
Yes, you are number 8. There are so many questions. This is interesting. I came across this as an undergraduate student, looking at malnutrition. I've heard of Adebayo very well. I know of the X, University of Munich, so I have questions. Okay, so number 1.
Thank you very much for the beautiful presentation. I just want to confirm. All right. Did you pull the data from 2013 to 2018? The 2 sets?
2003, 2008, 2013, and 2018.
Okay, so I was trying to see if in one of the slides, if you showed us the kind of trend analysis. So the effect.
Can you speak out so that I can get what you're saying?
Okay, did you study the effect of time? Because for you to have pulled those 2.
Okay, the way the DHL, the Nigerian Demographic Data Set is being arranged, it's arranged that you can actually pull the data. The data, the variables have the same coding. The same coding. Coding for child age, HW1 for 2003 is the same for 2013, 2008, 2013, 2020. So you can actually combine the data.
No, my question is, did you check for the effect of time? No, there's going to be a trend effect from 2003 to 2018. That's my question.
Yeah, that is trend, and that is what we did in when we are taking the.
Go to equation 4. I think it's around equation.
Yes.
You can go back to equation 4.
Just to be sure.
Okay.
Maybe I'm the one who missed it. Just to be sure.
I saw something 2003, 2000.
Yeah, you see the equation we consider trend. Yeah, you see the model.
Oh, okay. Sorry, I missed it. Sorry. Then did you use the base X software itself or how to base X?
The analysis was based on base X, and I mentioned that.
Okay.
Yes.
Thank you.
Okay. Number 2. Please, if your question has been asked because of,
Yes, good
just
morning,
tell us that.
everyone. My name is Dr. Mary Ade from Nasarawa State University, Kenya. Doctor, I commend your vocal presentation.
Thank you.
And much as my question is similar to what he has asked,
Okay.
I'm quite interested in your choice of data.
Okay.
The explanatory very, very good. The jump. I'm interested in why you jumped. 2003, 2008, 2013, and 2018. Okay. During your part, I got lost in some. Okay. I suddenly realized that stratification.
Okay.
And so I'm going to that comment.
I can't get at what point is what?
Did that come in based on your model? Because you talked about Kirby, Zamfara. There's a way you stratify.
Yeah.
So I'm also interested in that because you concluded in that line.
Okay.
Yes. So those are the 2 questions. Apart from that, I commend your presentation.
Thank you. Now let me take your first question.
No, you take it after the 3rd question. So we give you 3.
So I will not mix
Okay, take that. Okay, take that. Let's give it to 2.
Yeah, now for your first question that has to do with why the jump, we can only work with existing data. In Nigeria, democratic health survey data is not released yearly. Just like the Nigeria Malaria Indicator Survey data, it's released every 5 years. Every 5 years, so it's not released yearly. So the first one was in 2003 and then just like that. Now, the method for sampling, the sampling method is stratification, 2-stage stratification. Yeah, because of time, we didn't didn't dwell on that, but in the full paper, you will say it. Yeah. But if you really want to know more about the stratification, you can read the report. When the PSSN released their data, they go with reports for the data. And that report tells how the data is being dry, it's being taken and all. So the more about the stratification and how these states will be put into clusters, you will know more about that. So you can get it online.
Okay, thank you very much. Good morning, everybody. The presentation was very okay. I really liked it, and the topic is also interesting. Now, my question is this. You assume some prior parameters.
Yes.
And one would like to know, how did you arrive at those prior parameters?
Okay, if you go through, that is why I refer to the manual for base S. The manual for base S, because we use the base S, the software for the analysis. For the manual for base S, these parameters are by default. The Fish effect, the diffuse parameter, the diffuse parameter is being assumed. So if you go through that manual, you can see that all these parameters are by choice, by default in the manual. Yeah. Yes. You can, if you want to run your own analysis and you want to use another method, there are also choices for that. But we just work with the default parameter.
The question that was asked by Paul is very genuine. I will agree with me that the SS has been incorporated within the package. And that is done basically to aid the flexibility of its usage. You get it?
Yes.
So that you can, for example, in the choice of your prior, you can vary a number of things.
Yes.
That were ordinarily incorporated in the original basis by default.
Yes.
When you bring that into the hard environment, you can vary some things. You can relax on in line with your home data structure. And of course, in line with your home target. So that's why it has been incorporated within the hard environment. And there are so many, in fact, a number of packages, small packages have been written. So depending on what you are modeling within the Bayesian under this spatial temporal arrangement. So just take note of that. Go to your slide. Go to that your map. I have an interesting thing to show there, to tell you there. Where you have the stunting. Stunting results. Yeah. That's for the structured data. Let's go to the structured. Let's go to give me the result of the structured data. That's all right. Again, go there again. Yes. Now you may need to look at the data very well. Okay. Hello. I specifically asked them to plot through forward so that you can have. I know that there are groups in this area here. So, Doctor has firstly taught the number one day, work in this area extensively. You get it now. And I want you to benefit from the experience. And there are so many online people there too that will contribute. I'll take this again. If you look at this content by the legend of the map, okay? If you look at northeast, that is Maiduguri side. What you are saying there is that this country is not significant there. By that interpretation, okay? So that one may be curious. Why? That's why we have a serious number of ID due to the event of insurgencies over years, okay? And you are using the recent data, 2018 data. Is it not? So one will have been curious to see the effect of stunting to be severe in that environment. Okay? So the adjacent state like that you can see. But what to see we are that is shown to happen. If you go by practice in terms of analyzing the column of stunting, just do the descriptive statistics of the stunting spread. It will tell you that area have more children that are stunted than where you have the other one. So just take note of that. There could be mistakes during the data cleaning. During your data cleaning, there could be some small mistakes. It happens to even some of us to us. So when you are doing analysis, you need to be very patient. It's a big data. Every data that requires you to be meticulous while you are doing the cleaning, or you send it for analysis. That's very important.
Thank you, Prof.
Well, thank you, Madam, for your presentation. Just on a lighter mode, when you start presenting, I was expecting to see some references in the text. None featured there. Secondly, like Prof said, just in another way, but it's also based on descriptive aspect. I feel it would be nice if you have come up with a normal distribution curve that will display the WHO standard, then now put your own plot on it for us to see the deviation from the normal curve standard and our own data being stunted or underweight or overweight. So, and I don't know if this software does that. I've not used it before, but there is a software, WHO Anthroplos, because we have done a similar study, and that's exactly the software that we used. Maybe you can also try that. Or you get the article that we have published in this direction. All right.
I'm really interested.
Is it an open source?
It is.
Okay. Because we should be putting that to it. It's an open source. Tell us it's an open source. Well, all the questions are fine, but my own worry, like I put here, is that you said ethnicity and clusters were assumed to be placed under random effect. I expect to know why, because this is one of the very strong factors that explained some of this malnutrition issue. Then the second question I also have here is, see, we know that in literature, from the literature that I have read, choice of file has been a problem. Okay, and what we do to relax the mathematical complexity most times is to look around the conjugate prior so that we can simplify. Maybe, for example, you have a difficult posterior, you use your gift sampling to achieve convergence. Now, some of these restrictions seem to be more in base X. I don't know, I'm happy to hear that base X has been incorporated into how now. I've not looked at that. But this was a long time. I was a very, very small boy. I'm talking about my PS time. Okay, I had a supervisor who wanted me to download basics. I did it for my work. I worked on childhood malnutrition in your state, but don't look at that. That's not a research, as it were. Okay, because they are just at local level. But I read a lot of things about this there. So I need you to explain that aspect, because if you are restricted to a default that is on the machine, okay, then it speaks a lot about how well we can trust your finding. Do you understand? I understand that choice of this prior, for example, if you have gone through the conjugate prior, may give you a difficult posterior distribution, okay? But I still believe that since we have the likes of gift sampling, we can still achieve convergence, and that will suffice for that. I want an explanation on that too. Then the last question is under your recommendation. Yes, you have been able to, Professor has explained the other part of how well we can assume that this state mentioned actually experiencing this. But what do you consider the effect of the school feeding program? School feeding program in mitigating some of this? Because now we have noticed in the country misappropriation of funds as a result of the school feeding program. But with this kind of information, the federal government can now direct the funding to appropriate states that need it. Are you getting it? So I think that should find a way into your recommendation, and it will be a very good one. I don't know whether you want to react to some of this thing before we go to our online.
I've reacted partially more, except yours. That's the one you said about
Choice of prior.
all those choice of priors. We are trying to see how we can use our now. Yeah, we completely understand what you said is really true. Most of these things can be done. If I'm using the inland package, so we have been trying to see how we can get that done. For months now, I've been trying to download that package on my system, and my system is refusing to accept it. I don't know why. So we want to this special can easily be done in Arrow, where you can vary so many things. So, but you know, when you are just using this edge, everything is just there by default. You just press the pin and start running. Yes, yes. So that is just it. So maybe subsequent work should do that.
Okay. So let's take Professor Kazim, please.
Okay. I think everyone is hearing me, right? I first want to say good morning to everyone, and I want to commend the speaker. You know, you've really done a great job. But I'm actually asked two questions. Number one, I have a belief, the specification of any statistical model, we actually have error component. Because if I actually want to know how poor is my model, how good is my model, then I think we actually going to consider assumptions around the error. I did not hear, I don't know whether you mentioned that, but you did not specifically talk about assumptions. But I don't know whether your model is robust to that. I don't. So that is my first question. Now, my second question, you actually assume diverse prior for fixed parameters. And to the best of my knowledge, diverse prior is a non-informative prior. Okay, so what's informed, I mean, that, you know, decision. Okay, so my last question is, uh, you are actually implementing this within the Bayesian framework. I would appreciate if you compare this with a classical one without a prior information of the parameter apart from the one that are random, because the very first question, if one of my colleague will listen to you, because my colleague is not a Bayesian at all, it's a frequencies, and it's going to ask you to really justify by comparing your result with the uh classical one. Thank you.
Yeah, thank you very much, Dr. Professor Kazim. Now, starting with your first question that has to do with the model assumption. We did not develop the model. We are working within the Bayesian modeling framework, and so the assumption for that framework should also apply to our own. Now, going to the choice of prior, the question has been asked before, and I said we use base S, and base S by default, we just follow what we have on default. But from this, my take home from this seminar is to try to work within the R environment for this analysis, so that I could have the opportunity to vary most of these things that are by default. Now, for your third question that has to do with comparing with the classical method, where there is no end to research, we could also do that, and it come out as another paper where we compare the Bayesian modeling work with the frequencies. We hope to do that, but for this paper, we just dwell on the Bayesian. I hope I have answered your question, sir.
Okay, thank you. We move next to Dr. Chris. Please go ahead.
All right. Thank you so much. Now my contribution will be in the form of question and also an idea that's food for thought. Number one is that I didn't listen very well. The factors that you consider in your model for stunted growth. I'm sure you were talking so much about malnutrition, but I'm also sure that you also talk about some other factors. That's number one. Then number two is that I noticed that not every stunted growth is due to malnutrition. There are some people that eat very well, that they eat good food, and yet.
Doctor, please.
Yes.
Please, could you please move a little bit away from your system so that your voice is too loud here?
Okay, all right. I'm too loud.
Lower your microphone a bit. Thank you.
Maybe let me just stop. Let me just stop the second. The second one. All right. So am I better now? Is it better now?
Go ahead.
All right, sir. So number one, I said that perhaps I didn't listen very well. The factors you considered in your model that are responsible for stunted growth. I am very sure it should not be only malnutrition. Then number two is that not everyone that are stunted are malnourished. There are some people that eat very well, but they are still stunted. They eat balanced diet, they are still stunted. So did you consider the effect of gene expression in growth? Because we know that growth rates of any single cell, they are connected to the RNAs. and also to protein synthesis rates. So did you consider, because it is a food for thought, you have looked at the physical part, but you can also go into the extent of looking at the other parts that are not open, that are not revealed to the eyes, the effects of the gene expression in growth rates. Thank you so much. Otherwise, it's a wonderful presentation.
Thank you. In response to your question, I would say that as a researcher, you are restricted to the variables before you. Survey, you don't have a variable that say is the father or is the mother stunted or not. Hence, we don't have that variable. We cannot put that into consideration.
Yeah, I'm only telling you that you should consider it. Maybe in the next in the improvement of your work, can consider it. Because there are situations whereby both the father and the mother are stunted and the child is not.
Okay. Noted your.
All right, thank you.
Thank you, Dr. Prince. We are grateful for all the comments. Like I said, when you finish, that good work will always generate many questions.
And it appears we started on a very good note this morning. And this is to tell you that we are in for business today. So please, let's put our hands together as our presenters step forward to our seat.
Yes, I like the confidence displayed by the presenter. And that shows she is in charge of the work. And that is expected of a good researcher that is ready to improve. So the concept of fire is a big issue in the Bayesian inference. And of course, she has provided a right answer, but the nature of the variable that you are investigating determines the kind of prior you assume for that variable, okay? So it's not in all cases that by default we assume. There are reasons why you assume non-informative prior, and that could be useful at the end of the day to elicit good posterior distribution. So it depends on the nature of the variable of interest that will determine the kind of prior that you elicit. Thank you very much.
Okay, let's put our hands together for the presenter again. Let's put our hands together for her. You can see how concise the slide is. Please, if you don't know how to type in LaTeX, go and type. If you are not, go and learn. And if you are not ready to learn LaTeX, please, you can do a PowerPoint on normal Microsoft PowerPoint and it will be outstanding. Okay, so learning so that we have a PowerPoint and not a PowerPoint. Let's put our hands together for her. As we invite the next person, Dr. Victor. Okay, what do you have to say, Dr. Victor, please?
Yes, ma'am. Yes, sir.
Let's go ahead.
Thank you, sir.
Yes. What do you want to say? Do you have a question? Thank you. Just listen as we go forward. The next presenter, sorry, let me. I hope you can see your pen right. Yes.
That is Okorafo. Akwarawa. I know how you can imagine. Then Amadou, they will be speaking to us on T-normal, log logistic distribution, properties, and application to survivor data. Okay, please, you have 15 minutes. Okay, so please come. Leave the last one. This one down. This is down. Up. It's okay like that, so that we can see. Okay, fine.
Good morning, everyone. I'm here to present the paper on T-normal logistic distribution, the properties, and the applications. I'll be speaking on this outline. Now, over the years, we know that we have a volume of data in medical, health, and other fields that researchers have been looking for distributions where fit this data. And for this, it has led to convolution of many conclusions so as to take care of intricacies in the data that are being collected on a daily basis. We see that the data, as we have them in volumes, we see that single distributions cannot handle most of this data to give us accurate results. And we turn into convolutions, seeing the possibility of combining several discrete continuous distributions to get new ones that can handle this. It has been a big problem. We are motivated by this because we have so many bimodal longitudinal survival data that the analysis and the results have not been consistent with the data that we have. And some years ago, Professor Famoye, he proposed a distribution method. He called it a TRY method. That's an expansion and extension of the TX family of distributions. That instead of just using the uniform and the exponential as our contact function for the upper region, we could liberalize it and use any of the distributions, whether discrete or continuous, and then we'll be able to get a more flexible distribution that we can use in analyzing bimodal longitudinal survival data. We intend to propose a new convoluted distribution, normal chi-square logistic, and then derive the properties, estimate the parameters using MLE, and then also using the PSSN approach, and then carry out simulations and apply it on real data. We are restricted to TRY framework. The reason being, it has given us opportunity to liberalize the convolution of several continuous distributions. And then this will be very important to health professionals and people dealing with big data in health institutions. We have so many methods that have been used over the years in developing newly convoluted distributions. The differential equation by Pearson in 1942, the quantile function by Hastings, the normalization transformation by Johnson in 1949. We have the translation using normalization transformation by Vilborn in 1969, generalization of Pearson in 1977 by Dunning, and so on. We have so many methods over the years and what they've done. Actually, just like what we do in research, we'll just look at a way of improving on what others have done so that we can come up with a better result. And so this continued till 2014, that Ajara, Lee, and Famoye
now liberalized the method of generating the TX family, where they now removed the restriction that is on the upper region using uniform and exponential, and now we can use any of discrete or continuous distributions. And so we have so many distributions that have been generated using the convoluted approach over the years. Now, as I said, our methodology is just, we are using the TRY framework, where our base distribution will be the R, and in this case, that's the normal distribution. So we now have, just like I said, instead of restricting ourselves, we have three continuous probability distributions that we convoluted to have our own distribution that will also perform better or more flexible than the existing distributions. The Algebra 2014 has the CDF of the new distribution given in equation 1. And then in equation 2, we have the CDF of the chi-square distribution, which is our base distribution. And then we have also the PDF of the chi-square distribution, that's our baseline distribution. Then when we insert equation 2 into 1, we are going to get what we have in equation 4, and that gives us the CDF of the T normal distribution with logistic quantile function. Then in equation 6, we have, when we insert the PDF of our baseline distribution into equation 2, we'll get equation 6 that gives us the PDF of our new distribution. We also have the CDF of the PDF of the new distribution in equation 7 as well, of which in equation 8, thus we simplified further to get the PDF for the new distribution in equation 8. Now, what we've done, we also have done the maximum likelihood estimation. We have done the quantile function estimation using the maximum likelihood. We have done the ordered statistics. We are here to compile the results, and that's what the work is ongoing. Thank you very much.
Thank you. Let's put our hands together for Mr. Okorafor. Yes, I believe there will be questions. Please, we should also note that, especially some of our members that are still on their program are encouraged to also present their proposals and like that for input, to harvest input to make the work better. Okay, so this is an ongoing work that has been presented to us. There will be many questions, inputs into this work, both online and I've seen the hand of Professor Kazim. I know Professor Kazim worked extensively in this area. He will be able to give some advice. Let me also check if there are, okay, Dr. Chris is also interested in asking questions. Please, you can make use of the symbol online to show that you want to ask questions. If you have any question here, we can take it, Prof. number 1. Okay, that will make me number 2.
Thank you very much. Thank you, Mr. Okorafor. I can comment that the literature review was a little bit adequate up to some level, even though there are some new compound distributions that you may not have captured. Now, my question is this. Most distributions are meant to solve one problem or the other. You know, even from the beginning of distributions, it was targeted on maybe helping to fit certain data that ordinarily you wouldn't have found a distribution that would fit it. So in this, your new distribution, what type of data do you have in mind, you know, that you think it will help to, you know, fill a gap? For instance, because there are several new raw data that keep coming out every day that may not have any standard distribution that will, fit it. So it's just for me to know if you have any type of data in mind, or whether you intend to apply your distribution to certain data with a view to maybe checking whether it will perform better than some other distributions that are already existing. Thank you.
Thank you, Prof.
Okay, so you don't start for, or you want to quickly respond?
Yes, sir.
Okay,
Now, we are looking at bimodal longitudinal survival data. Any data, whether skewed or it's not skewed, that has bimodality, longitudinality, and the survival nature in that data, we know it's always complex to, get accurate results from such, especially for big data. So that's what our distribution is targeting at.
Prof will be number 3. I'm number 2, sir. Yes. I've not really answered Prof query. I've not really, maybe satisfactorily. Okay. And for a purpose, there are so many distributions that are existing, right? Coming up with a new distribution, it means you have spotted some deficiencies in some of the existing ones. Okay. And some of these are developed to capture data. Let me give you an example. Like lifetime distribution. So you have the exponential, the Weibull, and their likes. Okay? And you want to come out with another one. It means you want to sketch a graph, the theoretical graph, the empirical graph of the data. Now place superimpose on it the theoretical graph of the distribution. You now see some differences. Okay? You see that this does not capture this particular data well. Can we now have a model or a distribution that will capture that empirical better? Okay? You now want to modify maybe that exponential to see if it can capture. It means you already have a particular data in mind. So that's what one is asking. That, okay, for this data structure, there are models that have been developed, okay, but they are unable to capture sufficiently the data. I'm now coming up with this, that for this data structure, you can. So when you say, when you even say for any either skewed or not skewed, no. This model may not have that capability. Either skewed or not skewed, no. Okay? It has to be specific on a particular data structure. Okay? This one cannot be all doing kind of a model. No. Are you getting the point? So maybe for a particular skewed data of a particular structure, yeah, this will work. While some other contemporaries that are existing might not work. And you have to demonstrate this by looking at all those variants that are existing. End of your own. By the graphical method, you see how close are they, by whatever ANC or BIC, whatever, and see if your home is performing the results that you are. So that's the what you always ask. It's not sufficient to develop. I have students that have developed so many things. You must have the target. What is this doing that others have not done? You get it now? So,
thank you, Prof. Thank you, Prof.
Well, Prof has helped you, but whatever I will say now too will also help. Okay? Number 1.
The two professors have said, I want to suggest that you concentrate on already analyzed data that have been analyzed as other authors. Then you cannot analyze the same data with your own, although you can still make use of real data.
Thank you, Prof.
When you are implementing what
the president has just advised you. You should also look at the problem of not solving. Don't look at the problem of killing a mosquito using machine gun. All right, you know, you want to kill a mosquito, all you need is a broom. Then you now get a machine gun. It amounts to wastages of resources. Now, there is the concept of overfitness in modeling. You should look at that. There is a concept of over-parameterization. Okay, for any addition of parameter, it is also an increase in cost. Okay, an increase also in time. So, and don't forget the principle of sampling or the principle of our statistics is to what? Ensure that you have reduced costs and you save time. These two concepts are also very important. Prof has advised you as well on what to do. Now, where I'm going to is that you mentioned survival data. What do you consider the problem of survival data? Or what is even a survival data? Because if you don't have an idea of what a survival data is, modeling them in this concept, talking about skewness and all that, may not be the problem. Those of us that are in biostatistics, we talk about issues of having even of having censored or sensory presence or having censored observation in a survival data. These are issues. We cannot follow it up whether it is a right sensory or a whatever sensory. And that will take up whatever it is that you want to do in that area. It's very, very important to know that. So that the survival data that you have referred to here, you have an idea of what you intend to do, looking at the uniqueness of survival data. Thank you.
Thank you so much, Prof.
So we take Professor Dr. Peace first. Dr. Peace.
Thank you so much. I just want to make two comments. Number one is that the slides are too wordy. It does not look like a PowerPoint presentation. They are too wordy. Please, you have to work on them for future presentations. Then number two is that you made mention a lot about Professor Famoye. Now, can we know what Famoye did and what you feel you want to add to what he did? So what is new in your work? Thank you.
Thank you very much. Professor Famoye was with us 2013-14, and that was the privilege we had then to get into this information. So he was with us in University of Lagos, Department of Mathematics then, and then he was able to guide most of us on this path.
Yes, what I'm saying is that what's new thing? Like what did he do? What was his own contribution? And what is your own contribution now?
The contribution of Professor Famoye, as I said, was that before now, the upper region for the quantile functions was restricted to exponential and uniform distribution. You cannot use any other distribution other than exponential and uniform. But what Prof has done now is to liberalize that condition that we can now use even discrete distributions, continuous, whatever, even convoluted one, you can now use my own now as upper region and get a new convoluted distribution. So he was able to liberalize what was done in 2013 and removed that restriction that is on that upper region for the quantile function.
But you are yet to tell us what's your own part, because every research is to build on what has been done before. He has done his own. So what are you now bringing into this one?
Now our own part is we are now using that method to also get a new distribution that could handle and be more flexible in analyzing, complicated, complex data, having different properties in the data. So that method has given us a leverage in combining. For instance, it would have been so difficult bringing chi-square, normal, logistic, the three of them getting a common distribution without such a method.
What you are saying is that you have a generator that you want to put in probability functions to arrive at another distribution.
That's it.
But the question is asking you now is why? Why are you doing that?
Well,
most of these generators ask for one additional parameter for two additional parameters. Some often call them link function and all that. So why are you generating this new distribution?
Well, with what we've done so far, we have three parameters, even in this complex distribution, new distribution. They are just three. But the beauty of it is that we are always looking at a distribution that will be more flexible. That when we have big data, that the results, the analysis we don't get all the information we need. We still, even after this, there might still be other distributions that could perform better than this. So we are looking at the flexibility of the distribution in handling some definite problem, just like Professor Yaya has mentioned, so that we can address such problems.
It's okay.
Are you fine with that response?
Well,
thank you. Thank you. Don't worry, we will share your email with him, and you can also guide further. Thank you. Dr. Professor Kazim, please.
Yeah, I want to first give kudos to Professor, all the professors that have asked a question today. I'm going to say they are really speaking my mind. I think to the presenter, you need to do a lot of work, because I want to believe if Professor Famoye is listening to you now, I know he's going to challenge you on something. Now, I'm going to give some clarification now. I got my PhD in this particular area, and the question they were asking is, you don't just develop a model for developing sake. I'm going to say that again. There's always a reason why we actually need to put a statistical architecture in place. I'm going to give you an example, what I work on. The problem I wanted to solve is this. If you look at the one-way analysis of variance, there's an assumption. Assumption include normality. Assumption include constant variance, and so on like that. But when I look at normal distribution, what if in a situation, if I actually want to conduct analysis of variance and there's a violation of normality, what am I going to do? What I did, I look at the conventional F distribution. If you look at F distribution, before I can modify F distribution, I need to first go retrospective. Does that mean F distribution is not normal enough? If you look at F distribution, it's a ratio of two independent chi-squared. And when you look at chi-squared is the sum of square of a normal distribution. So which means F distribution has there's a normal distribution in it. And that is the reason why it is not, skewed enough to be able to withstand, that is the reason why there could be violations of normality. Now, you know what I did? I follow what Professor Famoye did. Professor Famoye provided a logit function that is asymmetric. I'm going to say that again. Professor Famoye provided a function, a logit, they call it a logit of beta, called asymmetric. What do we mean by asymmetric? That function enough is trying to tell you whatever distribution you put into the function will be asymmetric in nature. Even if it is asymmetric before, it will be more asymmetric, because we have different degree of asymmetry. Because I heard you talking about flexibility, Okay, the logic of beta itself, we have our parameter. The distribution you are introducing into that also has its own parameter. I heard Professor Yamaki talking about over parameterization. You know, if you have a complex structure, and that very complex structure, you don't really have the particular data, or that can address, is, to me, I'm actually going to refer to that as an exercise in futility. So what I'm actually going to advise you to do now, I want you to go theoretical. I want you to go to the base. I want you to go to the drawing board. Start from the individual distribution. What is lacking before you can actually think of combining that distribution with another distribution. I heard you talking about volume. It's not about data volume. But I say it's about three things. Let me tell you this. In statistical analysis, okay, we have modules that have normality assumption. We have module without normality assumption. Module without normality assumption, there's a lot of them. Now, you talk about the issue of skewness. You talk about the issue of kurtosis. Okay, so the survivor data, what is the nature of that requires combining probability distribution to that? So I think I'll better advise you now to go back to the drawing board, looking at the nature of the data, understand that, and see why you actually need to build a new distribution. You don't just build new distribution for building's sake. I don't know if I've answered if you really, I can give you my email. That is my area. We can talk about it. I can provide more materials, but the fact remains, you got a lot to do. Thank you.
Thank you, Professor.
Thank you, Prof. Yesterday, when you presented your paper, that was the more reason why I had contact with you, and I'll be very much happy to get in contact with you to improve on the work. But the other addition we've also seen, because in most of the distributions that we even have, whether the computational one or the newly convoluted ones, hardly do you see any of them using Bayesian inference for the estimation of the parameters because of the complexity of it. So that was why yesterday I was interested in your paper and your work, and it's good enough that I'm in contact with you. I'm very grateful. Thank you, Prof.
Okay. You're welcome. So any day I'm ready, I can chat with you, give you my email address, and we're going to talk about it.
Thank you, Prof, for doing that. Let's put our hands together for the presenter. After this, we will now be going back to our breakout sessions. I'm very sure the chairman for these sessions are already informed, and then we should just go as we did yesterday. If you are the chair of Group A, please join break room as platform 1. If you are the chair of Group 2, please join break room 2 and 3 for 3 like that, and C for 3, and so that we can quickly take some of our papers that are online currently. And I want to beg our presenters, please, for those that have participated since yesterday, if your slide is a power word, at least you still have some time to quickly work on it and ensure that you have a PowerPoint for presentation. Okay, after this parallel section, we'll come back to take 3 in-person presentations again, so that we go ahead with what we have for today. Thank you. So please, in a minute now, we should be able to see different rooms that we need to join. Please, you don't need to wait for us, just join the group that your paper is listed. If your paper is listed in group A, please join group 1. Okay? If your paper is listed in the group B, please join group 2. If your paper is listed in group 3, join group C, join group 3. Please, let's quickly do that so that the chairman can start the session
in earnest. Thank you. Hello, please, for those that are online, please just, you'll see more. Click on more, and you will see join breakout rooms. Then you can go to your own choice, whether it is 1, 2, or 3. Please kindly do that.
Which book are you?
Capture. Capture who? Ó ti wà ń bẹ̀. Ó ti wà ń bẹ̀. Ó ti wà ń bẹ̀.
Hello? Hello? Please, can anybody hear me? This is Dr. Missy Amla.
Many things, John. So, yes, I had an opportunity of yes, one key thing I think was more of like participatory approach to develop this. Most of all, to identify and what I was going to do. So, I was getting identify where are we getting where solving where are we getting the solution. So we can see that where so where are sources of data and what tools are we using to get the data. Looking at that also play. And also the frequency of reporting of data field. Terms of also the evaluation of how the
Oh.
When another things I also involved in that was also creating publicity apart from like to argument on like but then all this Please, let's return back to the main platform. All of that presentation has been collapsed, taken here. Discover that some of the platforms are having problems presenting. So please, those that are yet to present, will present online, you will hear it here. You will make contributions at the same platform and we'll move on from there. I want to thank all the chairmen that have been able to manage their session very well. Thank you so much on behalf of PSSN. We'll soon be back.
Hello, sir.
Please don't share this.
Ojo John.
Don't share this yet, please.
Yes, sir.
Done a little.
Yeah, thank you, sir.
Yes,
my name is Ojo John from the Department of Statistics, College of Physical Science, Federal University of Agriculture, Abeokuta, and I'm here to present comparative analysis of
all presentation will take place here.
on the effect of macroeconomic indicators on GDP in Nigeria.
Please, share the screen, please. Please control JJ, please. Please, those that are here, kindly mute your speaker. Please. We want to sincerely apologize to Collapse Hall for stopping those that are presenting. But we discovered that some parallel sessions have been having issues presenting their slide. So since this is the last day, we have decided to move all presentation to the main room for presentation. Kindly indicate your paper number on the chat page. Please indicate your paper number on the chat page, and with that, we'll be able to call you to share your screen. Paper number, if my paper is A4, I will simply just type A4 on the chat page. Okay? That's what we want to do now. Thank you. Okay, we have seen C38. Please, like I said, put your paper number on the chat page so that we can follow through. All right? So since we have C38, please kindly share your slide for presentation. Thank you. C38, share your slide for presentation. After which we take A34. Okay, if C38 is not ready, let A34 share his screen, please. A34.
Okay, sir.
Okay. This is who? C38.
Oh, C38 is ready.
Okay, please go ahead. You have 10 minutes for your presentation. Thank you.
It's okay. I am Chijoke Nweke. I'm presenting a work on the topic on the use of random iterative scheme for stochastic approximation results of convex feasibility problem. The work is co-authored by Dr. Udom and Dr. George Mbeni. from Department of Maths and Statistics.
Please go to your presentation, please. You have 10
Okay, sir.
minutes.
Okay, sir. Introduction. The stochastic convex feasibility problem is to find a point as defined in equation 1, where the C there is a finite family of a closed convex subset called a constraint, which can be represented as shown in equation 2, where the small letter c is a mapping from a metric space. It could be any kind of metric space to a real line. But if the solution in equation 1, which is the definition we gave in equation 1, is not consistent, what we mean that a solution is not consistent here is when there is no intersection between the solution. What the problem is seeking for is to maximize, to minimize the proximity function subject to those constraints in the work. So as shown in equation 3. Now, equation 3 is called a proximity function. Conventionally, there are two conventional ways you can represent a proximity function, which is the function you seek to maximize in a feasibility problem. One such way is to present the function as what we call convex combination, which is what is shown in equation 4a. Another way to represent it is what we call the convex composition, which is what we have in equation 4b. So, but in this work in particular, our interest is when the proximity function is represented in composition form, which is what we have shown in equation 4b. Now, there are few literature which have dealt with iterative algorithm of fixed point, approximate iterative algorithm, stochastic approximation, convergence of random fixed point, and all the rest of them. But specifically here, our emphasis is on when such a feasibility problem, convex feasibility problem, is stochastic in nature. Most literature you will see are deterministic, or what we call classical convex feasibility problem. But we want to extend this. That's what we showed in that last point there, that the study seek to extend the convergence result of a deterministic, or what we call classical convex feasibility problem, to its stochastic domain using composition form of its proximity function. The methodology we want to adopt here is a methodology which was proposed by Robin and Moron, 1951. He was the one that initiated this methodology of stochastic approximation, where he, given an equation in equation 5, he proposed a recursive algorithm to solve such an optimization problem as shown in equation 6. He said when a variable is being contaminated with noise, it is no longer correct to use a deterministic method of optimization solving problem algorithm to solve such problem. Such problem should adopt what we call a stochastic approximation method. So the equation is what we shown in equation. The recursive algorithm is what we have shown in equation 6. So here we are proposing what we call a stochastic extrapolated cyclic projection for solving this problem. That proposed algorithm is what we have shown in equation 7. This equation has some proof which, because of the mathematical distance, we are not able to bring it here. But our proof show that this equation 7 converges to a point stochastically, what we call stochastic convergence. And then we needed to give an example or illustration of how that equation converges to a point. So we just illustrated, suppose that a system could be an organization or whatever, have two constraints that could be represented in that function that is shown. Then the problem is just to minimize the feasibility problem as shown there, subject to those following constraints. You see error 1 and error 2 showing that this observation is being corrupted with noise. And then when you use equation 7, you're using equation 7, applying it to Robin-Mora recursive algorithm, you see the algorithm will be reduced to what we have done there. And then we needed to produce this numerically to show how does it behave. So numerically, at different error components, or what we call error bounds. We have error bound at 0.001, 0.0 to 5 decimal places, 7 decimal places, and 9 decimal places. We want to know how does this algorithm behave. So it's a quadratic function, so we're expecting 2 points of solution for that function. We presented here only the last 10 algorithms. Well, the first one, when the error bound is 0.001, the algorithm is not up to, the iteration, number of iteration is not up to 10. So we represented that. The last row there will show you the number of iteration before convergence were reached. We discovered that the point converges at minus 0.8 and approximately 1.7. And it was consistent for each of them, even when you change different error bound. So that result is what we have seen numerically in table 1. Concluding, the stochastic convergence feasibility problem in composition as an extension of its deterministic equivalence have been examined in this study. It has been established that the solution of convergence feasibility problem generated by the proposed stochastic extrapolated cyclic projection algorithm converges in mean square, that is quadratic mean, to a random fixed point. And what we applied is non-expansive mapping. There are several mapping that can be used, but what we use here is non-expansive mapping. These are some of the references that was adopted for the work. Thank you for listening.
Thank you very much, Chijoke Miki. So now it's time for questions and comments for the presenter. Any questions and comments from the floor before we go to online? Okay. Prof, you have the floor. Professor Kazi from UK. You have the floor, sir, please.
Yeah, Prof, I can hear you. I see Prof raising up hand.
Yes, Prof. We can hear you very well. Prof. Kazi. Go ahead, you have the floor, sir. Okay, you can now unmute yourself, Prof.
Okay, you can you hear me, right?
I can hear you, Prof, sir.
Okay, this is an interesting work, but I wanted to go to where you mentioned, I think 1951. I just want to say something about,
Okay.
yeah, 1951. Okay, now you are actually proposing, you want your algorithm to reflect stochasticity. And do you want to say, since 1951, there is no method, there's no algorithm that reflects the random components of this model? That's going to be number 1 question. Number 2 question is this: you mentioned consistency the other time, and you said maybe you refer to solutions, and you said when two solutions or when solutions are not consistent. I think I need more clarification on that. Did you get the two questions?
Yes, Prof. I get the good question. Okay. First question, 1951. Yeah, I know the literature seems very outdated, but the man is the originator of that stochastic approximation method. So it's not as if there are no other works that have been done. Most of the other works are just borrowing from the originator. We have several works that have dealt with issue of involving a stochastic aspect of an algorithm, but he invented and he originated that. That's why often we refer to him. Several other works you see is a version, an improved version of what we have done. So that's why I quoted it. We have several new works. Then on the second one, the consistency issue. That's why I said is a term we use for this particular, it's not the consistency in inference when we are talking about consistent estimator or not. That's not what we refer here. We mean if you have a set and that set, there is intersection of that set. We said that set, we said that in this work that is consistent. But if there is no intersection, what you will look for is where is the closest place for these sets, since they don't meet together. If there is no intersection, if there are intersection, you see that those inside that intersection, a point there will be the closest point. But when two sets are not intersected, you look for a closer point between those two sets. So that's what we mean by consistency and inconsistency here.
Yeah, I think that is kind of clear now, because I'm trying to, if you have a system of equation and you're trying to solve it graphically, you know, if you plot, you know, you're basically going to have two lines. You know, when the two lines intersect, of course, that will give you the value for X and Y. I want to believe that is what you mean here.
Yes, sir. Yes, sir.
Okay, only that those ones are deterministic, but the one you are introducing now is the one that have error component, right?
Exactly, sir.
Okay, fantastic. Thank you so much.
You're welcome, sir.
Unmute yourself, please.
Yeah. Are you hearing me?
Yeah, Doc, I can hear you, sir.
Yeah, please. Let me start with making a comment. You did not slide show your work.
Sir?
You did not slide show your presentation. I can definitely see what you have presented.
Issue, sir.
But
okay, sir. I'm listening to you, sir.
Yes, it's a nice work and interesting too. What we want to know the area of statistics that this thing can be applied.
Okay.
You showed an illustration and you tried to minimize the function. What kind of function were you minimizing?
Here, it was a quadratic function.
No, the constraints are quadratic, but there is something inside those two norms, the norm thing. What is inside it? Is it a function or what?
It's still a quadratic.
Okay, it's a quadratic equation.
Yes, sir.
Okay, you are using this to find the roots of a quadratic equation, the solution to a quadratic equation.
Exactly, sir.
Okay.
On the area of application, the area in statistics, this is operation research.
Yes,
we apply optimization methods.
Can it be used to maximize a likelihood function of a normal distribution?
Whether it can be used to
maximize the likelihood function of a normal distribution.
Once you can define a PDF of those variables and they can serve as constraint and you have a objective function, it can.
Okay, you may need to come down to statistical inference so that we see the benefits of what you are doing. Good work.
Noted, sir.
Thank you.
Thank you, sir.
Thank you very much. At this point, we call A34. Are you ready?
Yes, ma'am, I'm ready.
Okay. Share your screen, please.
Okay, ma'am.
Please let us unmute ourselves. Now let us mute ourselves as we allow the presenter to present.
Good afternoon, everyone.
Yes, please, you have just 10 minutes, please.
Okay, ma'am. I am Audin Najib Isiaku from Nassau State University, Kefi. My topic is meta-analysis of effectiveness of Janssen vaccination and prevention of coronavirus disease in some countries. My abstract: the reported outcome of coronavirus disease, COVID-19. This study was intended to evaluate the effectiveness of Janssen vaccination in the presence of COVID-19 in 3 different world regions: America, South America, and Africa, using comprehensive meta-analysis version 3 software. The data used for this research is secondary sources. This is the secondary data source on 1st November 2021 via Google search. Our findings from the results using fixed and random effect model show a summary effect of 0.00, indicating the Janssen vaccination.
Please go into your presentation. Leave the abstract, please. Go into your presentation.
Okay, sir. Introduction. A highly transmissible and hello, can you hear me, sir? My statement of problem: coronavirus disease COVID-19 is an infection disease used by coronavirus that appeared in late 2019. It is predominantly respiratory illness that can affect other organs. In view of the above, the US Food and Drug Administration, FDA, issue an emergency use authorization to permit the emergency of the unapproved product, Janssen vaccine 19, for active immunization to prevent individuals, yes, 18 of age and older, means and above. Objective of this study: the objectives of my study are to evaluate the effectiveness of Janssen vaccine 19, COVID-19 vaccine for the prevention and in America, Brazil, and South America, to evaluate the heterogeneity among countries under study, to interpret the summary effect. This is my literature review: Janssen vaccine AD.CoV2. This is a non-replicating recombinant human adenovirus type 26 that carry the full length. Then Janssen and Janssen COVID-19 vaccine ingredient. The COVID-19 vaccination from J&J Janssen contain a portion of a modified virus. Thrombosis with thrombocytopenia syndrome, TTS, is an uncommon yet dangerous side effect that results in blood clot, in large blood arteries, and low platelet count, blood cells that help form clot. more than 18.0 million doses of the J&J COVID-19 vaccine had been admitted in the United States as of January 2022. Let me go to my methodology. This research is a meta-analysis on effectiveness of Janssen vaccination in the preventive of coronavirus disease and in the United States of America. The data used in this research work was a secondary data sourced on the 1st November, as I said, reported the fact sheet for the healthcare provider administrative vaccine. Data analysis. The method employed for analyzing the data was fixed and random effect meta-analysis. The data were analyzed using comprehensive meta-analysis version 3. The effect size are standardized mean different and can be arrived at by dividing the mean difference in each study by that study standard deviation to create an index. The standardized mean difference can be estimated using the formula equation 1, where x bar 1 and x bar 2 are the sample mean in the two groups, and S within is the within group standard deviation pull across group. And this is the formula for S within, where N1 and N2 are the sample size in the two groups, and S1 and S2 are the standard deviation in two groups. The variance of D is given to a very good approximation by this formula equation 3, where the first term on the right of the equal sign reflect uncertainty performing a fixed meta-analysis in order to obtain the most precise estimate of the population effect. We minimize the variance to compute a weight mean in a fixed effect meta-analysis. Also, the variance of the study effect is estimated as using the equation 7. The estimate standard error of the summary effect is computed using equation 8. And the 95% and lower upper limit for the summary effect are estimated using equation 9. And finally, a Z value to estimate the null hypothesis that the common true effect theta is 0 can be computed using equation 11. For a one-tail test, the p-value is given by equation 12, where we choose positive if the difference is in the expected direction, or and otherwise. For a two-tail test, we use equation 13, where this is the standard normal cumulative distribution, and is Z value to test the null hypothesis that the common true effect 0 pi is 0. Prof?
Hello, sir. You just have 3 minutes now.
Okay, ma. Okay, ma. Let me go to this. The data presentation analysis. The data used for this research work is summarized and presented on the table below. Group 1, male and female. The mean for male is 55.6, while the mean for female is 44.3. and the control group mean is 55.4, while for female is 44.6. That is for age, yes. The data presentation and analysis, this is my continuation. The data below reported the information about the meta-analysis conducted on the sample obtained from the laboratory for analysis on 12 February 2021 to evaluate the effectiveness of Janssen vaccination in the prevention of COVID-19 in 3 different world regions: North America, South America, and Africa. My conclusion, based on the sample obtained from the laboratory for analysis on 12 February 2021, our findings from the result using fixed and random effect model show a summary effect of 0.00, indicating that the Janssen vaccination based on the study included the meta-analysis neither favor mortality nor survival. I-squared statistics is 0, indicating the total absence of bias. The variant of COVID-19 as at the time the vaccine was tried may have been overwhelming to be put under control, considering the deadly nature of the pandemic. However, the mere fact that the result do not favor mortality is a testament to a theory that getting vaccinated could mean middle symptoms in patients. These are my reference. Thank you. Hello, Prof.
Go ahead,
I'm,
sir. Go ahead.
I'm done now.
Yeah, hold on for your questions and comments, please.
Okay.
Dr. Yahaya, go ahead, sir.
Thank you, madam. How are you doing?
I'm fine, sir. Go ahead.
It's like you are a little bit far away from your mic. We can hear you a little bit faintly. Okay.
Please, Dr. ask your question.
Okay. Yeah, please, Mr. Presenter.
Yes.
Can you take me to that your equation 9 to 9, 10, 12, and likes? That your equation 9. Is it 9 and 10? Yes. Look at your equation 9. You have your L. Please make it in the presentation format. Yes. Look at your equation 9.
Yes, doctor.
You have LLM is equals to M minus 1.95 X SEM.
Yes, doctor.
What is that X?
That X.
What is that X for?
Okay, X is a dependent variable.
So if you want this, you look at equation 9 and equation 10. Are you with me?
Yes, doctor.
Do you really mean to write X there?
No. No.
And tell me the difference between equation 9 and equation 10. What is the difference between the two? What is the difference between the two? Huh?
There is a typing error here, sir.
Where?
From because both of the equation are the same.
Yes. So why is the error?
The arrow I supposed to remove one.
You're supposed to remove one.
Yes,
so if you remove one, which one are you going to remove?
I'm removing the second one.
Number 10.
Yes.
So you have only 95% lower limit without an upper limit.
Yes. Because
so what will be the upper limit? If you remove number 10. My friend, do you really
the upper limit
will be infinity?
No.
What?
The signs will change. One should be the negative and one should be positive, so that the lower limit is with the negative and the upper limit with the positive.
So that X should be
sir.
there.
Okay.
Should it be there? That X?
No.
What should be there?
Just the standard arrow. I will just the standard arrow.
Okay, so that X, I think you meant to write multiplication. Probably you just put X and just go over it. There is nothing like X or random variable there. Go to equation 12 to 16. The next page. Look at your from equation 12 down to 16.
Yes.
I can see your Z. You are putting it in 2 slashes. There is this slash, Z slash. What does that stand for? You have plus or minus slash Z slash.
Is absolute.
Absolute.
Yes.
So, oh my goodness. So
sorry,
sir? You say it's absolute.
No, before I put it, the p-value,
wow, my friend, look at equation 13 specifically.
Yes, for a two-tailed test.
You said psi, you open bracket, plus or minus, absolute, as you call it, Z. Then you say where phi of Z is the standard normal cumulative distribution.
Yes. Yes, sir.
So that equation 13, is that how you said for a two-tailed test by, what is that P? Is it a probability?
For the one-tailed test.
That P in equation 13, and even all the other P's even, in all the equations, are they all probabilities? My friend, is it is it your work? Or they gave you to present?
No, I'm the co-author.
So they gave you to present.
They gave me to present because
so
this
you didn't participate. You didn't participate in the work.
This is the first time of me.
No, forget about forget whether it's your first time of presenting or not. What is the difference between? No, madam, please, madam.
No, I participated. Actually, I participated on the work.
Madam. Yeah, what I'm saying, my friend, equation 12.
Yes.
Equation 12, equation 13, 14, 15, and 16. They are all P, and P. What is the difference between equation 12 and P in equation 13, 14, 15, and 16?
Doctor, I will take note on it. I will ask, actually, we did the work, me and my senior colleague.
Okay. Madam, okay. So, no problem.
Okay, thank you, doctor.
Okay, no problem.
Thank you, sir. Please, Dr. Osholale, you have the floor, so let's hear your question.
I know. Yeah,
I don't like it. Unmute yourself, please.
Ma? Should I?
Dr. Sholale, go ahead, sir, please.
Thank you very much. Sorry, without wasting time, the presenter, can you please go back to that equation 9? Are you there?
Yeah, I'm taking it back.
Equation 9, please. Equation.
Yes, I'm there, sir.
Very good. It would be nice you say 95% confidence interval rather than lower and upper limit for the summary effect. And at the same time, equation 9 and 10, you have to collapse the two by having m plus or minus. Is that clear?
Okay, yes, sir.
Yeah, go to your research design.
Okay, sir. Thank you. I will take notes.
Research design.
Okay.
No, you pass the play. Go on. You are no more there. Okay. Anyway, let me ask you. You are moving ups and downs. What is your research design for the study?
Sir?
Your research design for this study
is to evaluate the effectiveness of COVID-19 vaccine.
No, if you look at it, you have a heading, research design, and you did not state it. Your research design, it is a retrospective study. Because the data you made use of, you collected the data 12 February 2021. Am I right?
Yes, sir.
So you have to indicate that as your research design, not the method of analysis.
Okay, sir.
Thank you.
Thank you. Hello, Prof. Hello, Prof.
Madam Acha. Hello, Madam Acha. Hello, Chairman. Madam.
Okay.
Good afternoon, sir. Good afternoon. My name is Ojo John from Department of Statistics, Federal University of Agriculture. And I'm here to present on the work titled Comparative Analysis of Estimation Techniques on the Effect of Macroeconomic Indicators on Real GDP in Nigeria. So, introduction. The gross domestic product, GDP, is a monetary measure of all the market value of all final goods and services produced in a specific time period. The GDP nominal per capita does not, however, reflect differences in the cost of living and the inflation rates of the countries. Therefore, using the basis of GDP per capita at purchasing power parity may be more useful when comparing living standards between nations. Why nominal GDP is more useful comparing national economics on the international markets. Multicollinearity is the extreme problem for a regression model because it violates the assumption of the model, that is, the explanatory variable should be independent. Multicollinearity means there is a relationship between these explanatory variables. This relation makes overlapping between variables. Multicollinearity can cause serious problems in estimations and predictions, increasing the variance of least squares of the regression coefficients. And the methodology. So the methodologies used in this work are linear regression and ridge regression. In linear regression, the model specification is that dependent variable yi is a linear combination of the parameters. For example, in simple linear regression for modeling n data points, there is one independent variable, xi, and two parameters, beta naught and beta 1. Equation 1 shows the straight line of yi equals to beta naught plus beta 1 x1 plus error I, where I is starting from 1 to n. So given a random sample from the population, we estimate the population parameters and obtain the sample linear regression model, which is yi equals to beta naught cap plus beta 1 cap x1 in equation 2. Ridge regression. In standard linear regression, an n by 1 column vector is to be projected onto the column space of the n by p design matrix, whose columns are highly correlated. The ordinary least squares estimators of the coefficients, beta, which is a subset of r to the power of p times 1, by which the columns are multiplied to get the orthogonal projection, x beta is beta cap equals to x to the power of tx all raised to the power minus 1 multiplied by x to the power of ty. In equation 4, our b in equation 4, the k there in our equation can also be called a lambda parameter. This is what makes ridge regression. Without the k there, then our b cap will still be normalized back to the normal beta cap which we have in equation 3. So our k must be greater than 0, and our high p is the p by p matrix, identical matrix. From the table above, which is the correlation table between our variables, we can conclude that exchange rate and money supply are strongly correlated positively. This indicates that exchange rate is having an effect on money supply, which in turn leads to multicollinearity. The VIF values obtained after performing a linear regression in the coming slides will better explain the presence of multicollinearity in the predictors of variables. Figure 1 on our left shows the relationship between money supply and exchange rate. Taking a good look at the scatter plots, we notice how the data points are closely held, which could almost form a straight line from the origin to the IY values. The closed data point implies that one variable can easily predict the other, thus exhibiting multicollinearity. Our VIF values for our variable is being displayed in table 2. A general rule of thumb in determining multicollinearity is that VI1 is lesser than VIF value lesser than 5. There's a mistake here, sorry. VIF value greater than 5 indicates the presence of multicollinearity. From table 2, the circled number, exchange rate and money supply are having values greater than 5, which indicates the presence of multicollinearity. Multicollinearity in itself reduces the efficiency of the OLS parameter and thus cannot be relied on. We should know that the VIF only reveals if multicollinearity is present or not, but does not solve the problem of multicollinearity. In our next slide, we can find the coefficients for our OLS. The table 3 shows the coefficient of exchange rates, inflation rates, money supply, and interest rates respectively, estimated by ordinary least square. Since multicollinearity was detected using the VIF obtained from the OLS regression, then this implies that we cannot rely on the coefficients produced by the estimator for accurate predicting the dot. Thus, we need to find a way to eliminate the effect of multicollinearity in the data. This leads us to the application of ridge regression and its estimator. Figure 2 shows the effect of introducing a ridge estimator, lambda, in our model. The mean square error will increase as lambda increases. Therefore, our value for lambda should not be too high for it not to make our model too imperfect. We can also observe from figure 3 that there was a high value for lambda that made our coefficients, which are beta cap, converge to 0. Thus, it is important to use a value from the values of lambda that stabilizes our model. Table 4 is showing the results of our coefficients after performing ridge regression analysis. After selecting the optimal value for K using cross-validation method, we were able to use the value to minimize the MSE. Table 4 shows the coefficient of exchange rates, inflation rates, money supply, and interest rates respectively, estimated using ridge regression analysis. It is useful to know that beta 1, beta 4 of the regression yielded significant results compared to that of OLS. On the other hand, beta 2 of this regression did not yield significant results due to its very low correlation with other predictors in the data. Beta 3 remained the same compared to the OLS results. Our VIF value for our variables after performing ridge regression is being displayed. The VIF table in table 5 clearly shows that multicollinearity is no longer affecting the predictors variable, which are exchange rate and money supply, which implies that we can rely on our coefficients for better prediction. So the exact model for our data will be GDP equals to 1055201 with our beta 1, which is our exchange rate, plus 318013, our beta 2, which is inflation rate, minus 4 MSM2, which is our beta 3, minus 39015.8, multiplied by our interest rate, which is our beta 4. In conclusion, the variables of interest are GDP, money supply, exchange rate, and inflation rate. Our package was used to perform the analysis for both linear and ridge regression, and in turn prove the deficiency of ordinary linear regression and the sufficiency of the ridge regression in relation to the problem of multicollinearity. The results show that the ridge regression served as a remedial measure to the multicollinearity problem through the variance inflation factor greater than 5. Recommendation: clearly from the above analysis, using 2 methods of regression analysis, it was shown that OLS should estimate for better coefficients and show the relationship between the variables. Solving the problem of multicollinearity using OLS will mean 1, removing one of the predictor variables, or 2, reducing the data from the variables. But the ridge regression analysis has proved to solve multicollinearity problem without the elimination of a predictor variable or reducing of data. Thus, ridge regression should be used in place of linear regression, especially in data having the presence of multicollinearity. Thank you.
Thank you very much. Please, questions and comments? Questions and comments? Prof. Kazi, are you still raising your hand?
Yeah.
You have the floor, sir.
Thank you so much. I want the presenter to go to equation 1 and 2. Yeah, I want to say you've really done a great job, by trying to fix multicollinearity problem without discarding predator. But can you just tell me this? What assumption? I want you to tell me what assumptions was made in equation 1 before going to equation 2. What assumption was made? Can you hear me?
Yes, sir.
I'm asking you a theoretical question now. You have equation 1 and equation 2. What assumption was made in 1 to be able to arrive at 2? You're still hearing me, right?
After, yes, sir, I can hear you.
Okay.
It was after estimating the population parameters.
Okay. Let me ask you this. What are the assumptions of linear regression? Can you brief me? Can you remind me? What are the assumptions of linear regression? Okay.
Standardization.
Because you are fixing a problem without even knowing, I'm not going to say without knowing, let me just use the word without knowing the assumptions, because a certain assumption was made before you move from equation 1 to equation 2.
Okay.
So I want you to tell me the assumption.
Yeah, the normality of the data. The error structure.
Okay, so I think you still need to go to drawing board. Like, you need to understand some basic fundamentals. You have a simple linear regression now. The first one here is a population regression model. The second one is a fitted one. You are assuming expected value of error equal to 0, which is assumptions of linearity. With expected value of error equal to 0, that is why you have equation 2. Even though something is missing on y is supposed to have a cap too. So y is supposed to have a cap. Y is in statistics, we cherish notation a lot. So you need to get yourself familiar, you need to familiar yourself with your notation. In 1, beta naught and beta 1, the name we call it is different from the name we call it in equation 2. Now, I want you to go to the regular. I think you take note of that, right?
Yes, sir.
Okay, now go to equation 3 and 4, the one for ridge regression. Now, what do you think the value of k is going to be before you can move from equation 4 to equation 3?
The value of k.
Yeah, because the value of k is what justify your methodology, your ridge regression.
Okay.
So, because I'm seeing that as a generalization of equation 3. So, if you relax, if k equal to something, so I want you to tell me what that k will be before you can move from 4 to 3.
And k has to be 0.
What is the I?
The identity matrix is the high.
Okay, I think I'm going to say you go back to the work, get yourself familiar with notations. I think that's what I'm going to say for now. Thank you.
Thank you, sir.
Thank you very much, Prof. C7. Take down your slide, please. C7. Need to share your slide. As we're waiting for C7, P22, please get ready.
C26 is still waiting, ma.
C7, please share your slide.
A16 is waiting too, ma.
C7.
A16 is waiting, ma.
Please, if you didn't hear your number, that means you did not register, okay? C7, are you ready? B22. C7, if you're ready, share your slide.
Hello.
That's C7.
Sikiru, are you C7? You have presented before. Sikiru, you have presented in 2. Why are you sharing your slides?
C7 is ready. 67.
B22, please share your screen.
I still have another paper.
B22, please. B22, please share your screen. If B22 is not around, then we move straight to A24. A24. Is this A24?
C7. I want to share my slide. Hello, C7 is ready. Let me share my slide.
C7 is not ready, please. The screen is not showing. Your slide is not showing.
I want to share it. I'm trying to share it. I don't know.
We have called you repeatedly. You have not shared your screen.
It's telling me I cannot share my screen while other participants is sharing.
Please, whoever is sharing should please lower that slide first, please. Whoever is sharing this should lower the slide. Okay, C7, let's have your slide. C7, you are not ready, and we cannot continue to be waiting, please. B22, please share your screen. B22, please share your screen.
C26 is ready, sir.
Yes, I'm here.
Which one is this?
I'm here.
Which number is this?
B22. Oh.
B22, please, you may present. Go ahead.
Okay, let this person continue maybe after him. No problem.
Hello. Yes.
Mistake was done. Mistake was done. Who the data? Okay, after the so we now mistake.
Are you not set? Then come to the front, please. Don't sit down.
Please, you have 10 minutes for that, please.
Just go ahead.
Good afternoon. Good afternoon. My name is Matthew Efron. Discussing change point detection using moving index, the effect of regime change on petroleum price in Nigeria. So we have discovered that price instability of the crude oil in the world market has led to downfall of Nigerian economy. Nigeria is so much blessed with oil abundance, but the problem we have is that each time we change the regime, government regime, the price of petroleum also changes as well. So in this study, we have decided to look at change point analysis, not using the traditional change points, but using the moving index. The data collected comprises pump price of petroleum in Nigeria from 1st October to 1960 to 31st December 2021. There are many price changes during this period, but we are only considering 16 regimes, which are different governmental regimes in Nigeria. So we look at simple price index and also look at moving price index. We are actually doing this so that we can actually compare the price change in different regimes, how a different regime has actually affected price in petroleum. So if we look at what we have here, the moving price index is only comparing the current price and the immediate past price. Unlike the simple price index, where we compare the current price and a particular base year. And in simple price index, we often know that the base year is always a problem in simple price index. How do we know the base year? So that has given us a major issue in simple price index. But in moving price index, you're only comparing the current year and immediate past year. So looking at table 1, we have 16 regimes, and those are the regimes, starting from Sir Abubakar Tafawa Balewa down to President Muhammadu Buhari. So this 16 regime, we have different prices in these regimes. But sometimes in a particular regime, you can have more than 2 prices or 4 prices. What we did, we took the average per regime. So that's why we have just 16 points. So if you look at the plot I have here, I have yearly plots from 1960 to 2021. At 1992, you can see that there's a skip in the price of petroleum, and it went up like that until 2008, thereabouts. It came down and it went up again. Looking at it, you say, oh, there's a significant change in prices of petroleum. But looking at what you have for the simple price index, you see that the change is very significant, starting from the Babangida regime to Cheneko regime, and it went up like that. Let's compare the simple price index and the moving price index. The simple price index, if the price is 100, we say there is no change in the price of petroleum. But if it is above 100, we say there is an increase in price. And if it is below 100, we say there is a decrease in price. Looking at the simple index, the price skyrocket from the Bangda regime, which is 972 to 5,000 increase during Shoneko regime, and it went up like that. It would be very unfair to use this particular index to compare price of petroleum. But if you look at the moving index actually showed that it was during Bangda regime that there was a hike in petroleum, while other regimes still maintain, though above 100, but still maintain reasonable increase. So we now went ahead to fix an hierarchical polynomial model on it, and we discovered that time also have major effect on the prices. If you look at the one for moving price index, we discovered that it went up and it later came down. So t-test was used to look at the differences in those indexes. When we use simple index, we discovered that there's a significant difference in those changes. But when we use moving index, the difference is not significant at 5%. So in conclusion, the study has investigated the impact of change in regime on petroleum prices. And some of the conclusions we have made that the change of regime in Nigeria has impacted so much on the price of petroleum, because each time we change a regime, we always have change in petroleum prices. Then the trend of the change in petroleum prices using 1960 as a base year, which is quite far, shows a significant difference in those price indexes. But if we use the same thing using moving index, we discover that there is no actual significant change in the prices of petroleum. Thank you.
Thank you very much. Time for questions and comments. Time.
Good afternoon. I would like to ask a fundamental question. In the literature, I don't know, were you able to track the fact that there's a relationship between change in regime and change in the price of petroleum? Because there are a lot of factors that are responsible when it comes to change in the price of petroleum. There's a difference between causation and correlation. That two things correlate together does not suppose that one affects the other one. I do not actually agree. And for example, there's what is called oil glut. Oil glut talks about the reduction in the excess supply of crude oil in the international market, responsible for the decline in the price of crude oil. We also have oil boom and the likes. There are a lot of factors responsible for change in the price of crude oil, not necessarily regime. I just want to find out, in the literature, was there any link to show that change in regime causes effects in change in the price? Thank you.
Thank you. When we talk of change in price, many things can affect the price of petroleum. Even
the value of the currency against dollar can affect it, which we all know that one of the major things that is actually affecting the pricing generally now is the fall of naira to dollar. We can also talk of time, like what we have here from the analysis we have here. Time can also affect it because no matter how it is, the further you go from the base year, time changes and most likely things increase. Even if naira is stabilized to some extent, the price of things will still increase because it will not be the normal income we have been earning that will still be earning up to now, even if things were to be stabilized. But we have looked and we have seen that there are some other factors, like for instance, when we talk of subsidy. Subsidy is one of the major factors that affect the price of petroleum. If there is subsidy, then the prices will come down. But there is no subsidy, there is likelihood that the prices will go up because we'll be buying it at the normal price that we should buy it. So subsidy, change in the value of naira and some other things can actually affect the prices of petroleum.
Thank you very much. Olalekon, please, you have the floor. Unmute yourself.
All right. Hello, can you hear me?
Yes, sir.
Yes, sir,
Yes.
I can hear you. Go
Yes,
ahead,
hi. Yes, thank you very much for a very good presentation. I always appreciate everybody that sits down to put something together for us. It's a very good job. Thank you very much. However, I listened to the work from the beginning. I've also done some work on change point detection. Can you hear me?
Go ahead, can hear you, sir.
Yes, and I know and I can see that you are actually working on the price fluctuations, how the prices changes from regime to the other, from one regime to the other. Ordinarily, that will not be called change points. That will have been something like the fluctuations in price, time series fluctuations of prices from one regime to the other or something. I would have preferred that you adjust that title away from change point detection, because if you want to call it a change point detection, the first thing you should have done is to first of all investigate the theory of change point to see whether the data is dependent or not dependent. In your own case, I can see it's dependent on time, on the previous time. So those are dependent observations in your own case. I think I want to advise that you look more into that title, because the theory of change point, I don't think it will fit very well into, putting it as if you are interchanging change point for price fluctuations. As far as I know, change point detection has to do with sudden changes in statistical distributions, after a particular point. We have single change point, we have multiple change points and all that. So that's an advice on the title.
Noted.
That's an advice on the title. Thank you very much.
Very much, sir. C26, can you share your slide now? Prof, you take your question after the next presenter, please.
Hello, good afternoon.
Good afternoon. Go ahead, share your slides.
Okay. Can you see it now?
C26, right?
No, A19.
No, C26. C26, are you not ready?
I'm ready, ma.
Share your slides.
All right.
A19 is on.
No, B22 is here.
A19 is ready.
A19 is ready, sir. A16.
Oh, I will please not doing it according to how we came.
A19 is ready.
Oh, right.
C26 should share his screen for presentation. Thank you. C26.
Yes, I am sharing.
A19.
C26, share your screen. A19, you are not registered for the conference. You are not registered for the conference, please.
Good afternoon, all.
Emmanuel, we're waiting for you, please. C26.
Yes, this is Emmanuel.
Emmanuel, go ahead, please.
C26 presenting. I am presenting the title.
We are not seeing this slide now.
It's showing already.
No, we are not seeing it.
Matthew Oyeni, please stop sharing. Let us take C26 first. Please respect this order.
Okay, sir.
Emmanuel Ikegu. Emmanuel. Unmute your microphone.
Please, Emmanuel Ikegu, share your screen for presentation. User, please stop your video. Please stop your video now. We expect Emmanuel Ikegu to share his screen. If he's not ready, then we'll take B22. Emmanuel, share your screen now, please. It appears Emmanuel is not ready. Okay. Your screen is coming.
No, sir, Emmanuel, we're waiting for you, please. Emmanuel, are you there? Emmanuel, if you can hear me, talk, please. Emmanuel, if you're not ready, I'm checking another presenter, please. B22, are you ready? B22, can you hear me?
Yes.
Please go ahead and share your screen.
Can you see it?
Sir, go ahead.
Yeah, thank you. The topic of this paper I'm presenting is analyzing non-linear relationship using spline regression model. And the way I've structured it I have introduction there. I want to talk about the error committed while analyzing data sets using economic, medical, and other kind of data. And so which do not have linear structure that have been wrongly analyzed by using linear models. So this has led to misspecification of models in many cases. Of course, we have so many wrong results and predictions. So this paper seeks to address this issue by recommending spline models using a nonlinear simulated data set. So before I go to the real model which I apply here, I want to talk. I want something about regression model generally, which we're all familiar with. You know, when we are talking about linear model, once we see the data in statistics, we believe it is linear. So this is just a summary of what we normally do. If you're interested, you know, we all know that a linear model, what we want to do there is trying to predict the response variable, believing that there's the mean. I mean, we have a predictor that is having mean relationship. So, and when it is not following that, we say it is quartile distribution or quartile regression. So if it's having mean, we now ask ourselves, is the relationship linear? When it is yes, we go to linear model. The other thing that comes to our mind is, can we transform the data? If it's transformable, that is using log, transformation of different kind we have in statistics. We can introduce log, we can use cosine, we can use sine. It depends on the one we want to do anyway. But we now find out again, can we find an equation? This is another question we normally ask ourselves. Or for the curve, if it is no, we go to GAM, that is generalized additive model. Then or we go to nonlinear model, of which I'm talking about now. So I want to say something about linear regression, which we all know. So in linear regression, we model the possible relationship that may exist between two continuous variables. That is by fitting linear equation to the observed data. So this part of my literature review now, there should be a predictor variable and response variable. So the equation, this what we call linear equation, is called the regression equation. So X is the predictor, while the response variable is Y. The regression coefficient, we all know this. So I want to move to where I'm going. So I want to compare some regression models with the one I'm talking about. I want to talk about, that is spline regression. So the first one on the list is I've talked about linear. The second one now is polynomial regression. So polynomial regression is a type of regression which employs a non-linear function according to these authors. In regression, in polynomial regression, extension of linear model is done by adding some other independent variables. So the real predictors are raised to a power. For instance, in a cubic regression, 3 variables we have raised to power of 1, power of 2, power of 3. They are used as the same predictor, but raised to different power, that is different degree. So in order to turn a linear regression to non-linear now, the method is replaced by linear model with a polynomial function. So the standard method to extend this linear regression to a non-linear relationship between the dependent and independent variable is this, which we have as y equals this. So the last degree there is a p. So by the time we are increasing this, one problem we are having with polynomial regression is that we can have overfitting. We can have overfitting, and it's one of the demerits. As good as polynomial regression is, the problem it has is this introduction of overfitting. That's why at times R square will give you 1, and you say your data or your model is excellent because you have R square over 1 or 0.99. It is what has been made. It is one of the problems we have because the power keep increasing. And one thing that normally deceives us in statistics is that you see your R square increasing, you say the model is very, very good. That's why people outside statistics, but they are using our methods. They are happy. But eventually, you see that the prediction will be having issue because of the model we have used. Now, spline regression model. The problem we have with a polynomial regression is what spline is taking care of. In order to overcome the overfitting, which is a major disadvantage of polynomial regression, so instead of building one model for the whole data set, so the data can be partitioned into many parts. So and come up with various models. So it's like we're having the one I make bold here. It's like which I call junction. Though literature call it knots, but I call it junction or points. Where it's like when you are tying rope. So at which you are tying, maybe you are joining that rope to it. So those points are the knot at the junction. So at each of the joint or junction, what spline does is that it will now break them into many parts and come up with the various models. So if I show you the kind of model that come up after this, it is a long one. But what we after there is what is doing over that of polynomial. Now, this is spline regression model. So the piecewise cubic polynomial with single knot at a point is this. So this is 1 point here. This is the first, which we refer to as the intercept of the model. So for the first one, so if xi here is less than the point here, this is how it's going to look like. So if it is greater than the c, that is the second point, this is how it's going to look like. So different polynomial can be fitted to the data. So one, actually, what I did here, I did not collect any data. I simulated it. I simulated data that are not linearly related, so as to give me to be able to test the robustness of this data. Of this model. So the first polynomial function has this coefficient. You can see now the second one has this, third one has, and so on. Second one has coefficient of this. These are the coefficient. So application to simple function of the real distributor can be made by using this polynomial function, which I put there. So another one we are talking about here is GAM. GAM is generalized additive model. So using universal smooth function. This author is a very popular one. Those are people that have used his word. I mean, they have his book, you know what I'm talking about. Talk much about GAM. So I just summarize what he used in his work. So where I'm going is this: f of x is our response variable, which is f of x having this. So here, when we combine, to begin with, we must consider a basis to use as a basis that f is element of. Yeah, so the element of the part of the predictors. So doing so leads to choosing a set of basis function bj, which parameter of yj that we combine to produce f of x, which is, I'm trying to explain what is here. So the cubic polynomial can be used to express this better. Where I've broken is here. The b sub 1 of x is 1, b sub 2 of x is this. Replacing this here, we're going to have it here. Gamma 1, 2x raised to power 3 and this. Now, coming back to this, we will see the result this one is going to give us by the time I introduce data into this. So data and data analysis here, data used for this paper is through simulation, which I said at that time. So two sets of 1,000 observations that are not linearly related were simulated, as I've said. So all analysis were carried out using our version 4.13, that's R code 2022. So this is the scatter plots showing the nonlinear relationship between y and x, which I initially talked on when I was simulating that. So this is an example of nonlinear relationship. You can see from this the y and x. Everybody knows that this is not linearly related. So now fitting a model to this, if you fit this model to this because it's linear. Linear has to be linear on it. So this is what we call line of best fit. So this is the model. We can see that this is not okay. So this is the model diagnostic for the linear model. Looking at the residuals, this is contravailing what is in the literature because it's not supposed to have a pattern. Then look at the normal. This is not straight. This normal QQ plot is supposed to have the point here is supposed to be straight, at least a little bit straight, not so much deviated from the line. The histogram of the residual, look at it, it's not normal. Now it is not symmetrical. It's not symmetrical in nature and the Cook distance. So here, look at the spline regression fitted model. So it's giving us, okay, this is it here. These are the estimates. At each knot, we are having 6 knots here. The way it is designed is that it continues to iterate until it gets to where it will not give us significant value again. So for the first knot, is giving us they are all significant except knot 1 and knot 2. It continues like this. These are the estimates and these are the standard error. So now this is the spline regression fitted curve. Looking at the curve here, you can see it picks most of the points. When you compare this with that of linear, see there's quite a big difference. You can see. So now the same thing when we move to model diagnostic for spline model. You know, in statistics, it's not only chart. We need to prove what we are doing. So with some other diagnostic methods. Now comparing these now residuals, you can see this one spread out, and look at the normal QQ plot, always almost straight on the line. Then the histogram of the residual also, this is symmetrical. Now, and the Cook distance, bringing out the values that are we call maybe extreme values out, and they are not many. So here, this polynomial regression fitted model has 4th degree. At 4th degree, though this polynomial model here is supposed to stop at degree 2, because anyone above degree 2 is no longer significant at 5% level for as 5% level. So by the time we move up, then we look at the polynomial regression fitted curve now using this. This is what it's giving us. Now, ideally, if I want to stop at polynomial regression, I'm supposed to stop at degree 2, as I've said. And this is the line is giving us for prediction. Now, this is model diagnostic for polynomial model. When you look at it, we may say that this is very close to that of spline, but it's not so. And look at histogram of the residual. Almost, we can say it's having a best shape, which is always what we want, but it's not as symmetrical as that of spline model. Now we are going to do some other things. Here we have the GAN fitted curve, the same thing we have here. I'm after we want to know which of them is better. This is log transform fitted model. The p-value also is up at because it is just we transform. What we do here in log transform fitted model is that we just transform the data. This log. By the time we introduce log to the data, you know what you're going to have is going to be different from what you have before. The only problem we have is that when you have negative, it poses problem. But here, now comparing all of their results, because of our time, goodness of fit, I now put all of them here. The 5 models: linear, spline, GAN, polynomial, and log transform. So AIC and BIC. So authors say we cannot be using the 2 of them together for comparison. We should pick one. But I still put the 2 of them here, so we can pick one. Now, assuming I'm picking AIC, linear as the highest, followed by log transform, meaning that they are the worst. So the best here, spline is the best, followed by GAN. Polynomial is also very, very high because we go for the minimum. Now, look at the summary of model performances here. And this is RMSE, MSE, ME, and R square. Though a lot of people stand against using R square for picking the best model or talking about model performance when it comes to spline. Well, I am not using it, but if you are to use it, it's still the lowest because 0.8, I mean, it's still the highest because we are picking, we are going for the highest R square and the lowest root mean square. And the lowest of all this R square should be the one that gives us highest is going to give us the best model. So comparing this, we see that GAN has the highest, but since a lot of authors are standing against usage of R square when we are comparing model, I mean non-linear model. So that's why I stop here. So I want to summarize my findings now. It can be observed in the table that regression spline model and GAM have minimum values of metrics. So this means GAM also perform well in terms of model performance. This established robustness of spline regression spline model. So conclusion: the results from the tables and figures in this paper are proof that a regression spline model have performed other models considered. It is therefore recommended that the model be employed when dealing with non-linear data. These are some references I can put here. Thank you.
Time for questions and comments. I can see Dr. Deboye, please unmute yourself.
All right. Thank you, Dr. Acha. And I want to appreciate the presenter for the beautiful presentation and his contribution to knowledge. However, I want to make inquiry about the following. First, on the issue of his result table, can we now say that GAM model is better than his spine regression model? Because looking at the RMSC, a GAM model is even like 0.001 lesser than that of the spine regression model. And also, I want you to move the slide to his specified spine regression. There is an inquiry I want to make there on his specified spine regression model. Thank you.
Thank you very much, sir. Please, C26, can you share?
I'm expecting the presenter. I'm expecting the presenter to show a specified spine regression model. I want to make an inquiry on that model.
Okay, sir. Go ahead, Emmanuel. Go to the slide so that you can.
Please go to your specified spine regression model. I wouldn't remember the equation number, but where you specify your spine regression model.
Hello, ma.
Yeah, go to the page that you request. Go to the page.
No, that wasn't me.
Put on slide. You had the question, right?
That was the previous presenter.
Put your slide.
Hello, I'm back. Okay, sorry.
I think another slide is being shared.
Okay.
We have another slide on the screen already.
All right.
Okay, I think he can go on.
Go on, please. You go on, please.
Okay.
Answer the question raised by Dr. Adeboye.
Sorry, I was battling with network. So please, Dr. Adeboye, can you take the question again?
Can you repeat your question?
Yes, I said on your research table.
Yes, sir.
The GAM model RMSC is 0.001 lesser than that of your spine regression model. Can we now say that GAM model is even superior to your spine regression model? That is one. Then secondly, in your specified regression model, the XI there, what will be the range of value for your XI in the specified spine regression model? But it sounds confusing if you go back to that model.
Okay. Now look at, okay, I'm there now. GAM for MSE is 0.625. For MSE is 0.6. For okay, you are talking about RMSE.
Yeah.
Okay. Yeah, I'm looking at MSE. Okay. But well, the two of them go together. You know, we cannot use R square, but the two of the RMSE and MSE, we can pick any of them. And if you look at MAE, it's still lower.
Hello, Adele.
Sir? Yes.
Hello. What Dr. Adeboye was trying to ask was that looking at your MSc, it seems the MSc confers advantage on jam over spline. Whereas it didn't look very well at your other metrics. You have used the BSc, you use the IC, and you use the half square. In all these three instances, the spline model was better than jam.
Yes.
Spline model is okay under that conditions.
Okay, I understand, sir. I now understand.
So that is,
thank you.
I don't want to use RMSE alone to determine it. I consider other ones.
Okay, sir.
Yes, sir. Then the full model is in my work. I mean about spline, where I have it written.
Thank you very much.
Yes.
C26.
Have I finished answering the question?
Yes, ma. I'm coming up.
Thank you.
Okay. Let's see.
No, we're waiting for you.
Okay, I'm coming up with it.
What I lost in that presentation. At least. Okay, me balẹ̀ báyìí. This is a presentation. Ẹ mọ̀ kẹ́sì ṣẹ́kẹ́ mọ́ lèyàn present.
Please, Emmanuel, what's going on? Share your screen.
Yes, I am sharing it.
Okay, good. We can see your screen now.
You can't see it yet. It's coming on.
Go ahead. You are seeing it.
All right.
Joy.
Good afternoon, good afternoon all. Emmanuel Ikegwu is my name, and I'm presenting this paper with Dr. Onyeka Obaka on the title Markov Switching Autoregressive and GAC Models, a comparison of volatility models with application. Well, it's evident from the complexity of events of these days that the traditional modeling techniques, which assumed linearity and the Gaussian process, do no longer hold. And so a lot of, in the field of human endeavors, we realize nonlinear models are becoming conventional with regards to the complexity and interrelatedness of the phenomena considered. And so we're looking at the dynamism of these time events, and our main aim here is to look at those models that do not assume linearity, the nonlinear models, of which Markov switching is one of it, and then ARC and GAC models are also part of it.
So you have to do that before.
Markov switching models have been applied to economic, financial, environmental, epidemiological, physical, and other areas. And some of them are what we see here: stock market performance, modeling stock market returns, exchange rates, implied volatility of market indices, and a host of others. Autoregressive conditional heteroscedasticity models of order P was also applied to model volatilities clustering in time series generating function, which results in diverse periods. And so with this varied application in different fields, our study explores and compares the volatility models, incorporating the regime of Markov switching models and the generalized autoregressive conditional heteroscedastic models, with the aim of recommending a better fit as applied to the Osher index return in Nigeria. Here, methodology, we see the model specification for the Markov switching autoregressive model shown in equation 1. And then where the CST, which is the switching component, is given here in equation 3. And these are state-dependent means, whereas the QST is the state-dependent variance. And the phi's are the autoregressive coefficients produced by different sub-samples. The study model the regimes SIT for the states at 1 to M are the outcomes of the unobserved M state Markov chains with ST independent of the error term. The Hamilton in 1989 gave this model of the Markov switching model However, Mendy and Widodo gave the present model we are looking at in equation 4. The coefficients of its autoregressive component contingent on ST are separate unobservable variables. The transition probability is given in model 5, while the transition matrix is given in equation 6. For the GAC model, we adopted the one used by Brockwell and Davis 2016, as shown, and Shumway and Stouffer in 2017, as shown in equation 7 and 8, while the ET are actually the standard Gaussian white noise, and the ZT, which is our returns, is given in equation 9. Now, taking the difference of these equations 7 and 8, we came up with equation 10 down to 12. And we are seeing that the EI square minus 1 in equation 12 is a shifted random chi-square degree of freedom. And so this gives us the ARC1 model process for ZT. Here we have the estimates of the expectation and the variance of our return as equation 13, and the variance as equation 15, contingent on the alpha 1 being between 0 and 1 over root 3. The kurtosis also is shown in equation 16. And here we look at the general ARC-P model shown in equation 17 and 18, and the generalized ARC model shown in equation 19. All this was what we considered, and here is the Usher index from 1985 to 2019, which was used in the study. And here is the returns, which is the difference value of the Usher index. Here we have the descriptive statistics of the Usher index original and the return, which is the ZT. And then we tested for heteroscedasticity, and we concluded that the model is heteroscedastic in nature. And so here we tried to estimate the parameters of the Markov switching autoregressive model with regressors. And using the AIC, we concluded here that the MS3AR3 is the beta model, and that was what we fitted here in table 4, looking at the model with a regressor. And here we also have the transition probabilities of the model as was given in the table here. So from the study, we make these conclusions that the Markov switching autoregressive model, Markov switching of state 3 and 3 autoregressive components was the most appropriate with the least AIC. The transition probabilities of the state was also generated, and we saw that the accumulation period has a remaining or a retainership probability of 95.6, the big move up 99.7, and the panic phase 97.9. However, the essence of the work was to compare the model with that of the GAC. However, the work is still ongoing, as our next stage of the work is to estimate the GAC model and thereby make the comparisons. Here is the references that we used in the work. Thank you so much for listening. Hello, ma. Hello, moderator. I'm done here, ma. Thank you.
Dr. Acha, the presenter is talking to you. Mr. Ikegu, maybe you take your bow and leave.
Thank you so much, sir.
I have a question.
Why the moderators has muted?
I have a question, please. Hello.
Go ahead with
your.
Go ahead with your question. The moderator has muted herself.
It's all right. I want to sincerely appreciate the presenter for wonderful presentation. Just though you said that the work is still ongoing, sir, but looking at you are comparing the regime together with that of GAC. Am I right?
Yes, sir. Yes.
Now, but already you have your data, which you have already concluded with the Markov regime, isn't it?
Sure. Yes, sir.
Since you have the data already, even though the work is going on, since you have the data already, you should have analyze or estimate for the GAC model as well, so that since you are comparing the two together, so that you'll be able to make your final conclusion about it. Because if you are trying to compare two things and you analyze one, while you say the work is still going on concerning the second one, then how can we really justify which of this model is actually the best? You understand what I'm saying? Because
I got it, sir.
Because I believe with your data, having your data already, the same returns you have, you can easily compute your GAC, the estimation of the GAC, and you get your result within few minutes and also give your conclusion. So to me, I think you should have tried to analyze the GAC as well, so that you'll be able to make a better conclusion.
Comparison. Okay. All right, sir. I'm very sorry. We are yet to get there. I will do that, and maybe the publication, I'll be able to show that, sir. Thank you, sir.
You are welcome.
Time is ready. No.
Okay, because I don't got too much.
Right, Khalid. Likewise, B25. Good. The chairman. B25 is ready.
Graduate,